Hi everyone, and welcome to our video on finding an angle on a triangle by using the law of cosines. All right, so to find the angle, first thing we should probably do is label those sides. So we have all the angles labeled already. Remember, going directly opposite of the angles are the little sides, or the little letters for the sides. So little a is 12, little b is 15, and then little c is 11 and a half. Okay, so we've got our setup there. Now, just like before, I'm just going to scroll because we have the previous problem up here. If we were to try to do the law of sines first on this problem, notice the whole tops would be left as the letters because we don't know any angle. So A, B, and C, capital A, B, and C would be unknown, which means that we would, again, not have a complete fraction. So that means we can't do the law of sines. All right, so instead, the law of cosines should work then. All right, and we need to find angle C. So again, I'm thinking of the formulas for law of cosines, and well, I know that the letter that I want is at the end. So it's either little c or capital C that I'm trying to find. Well, I'm finding capital C, but for the formula, I want to start with the little c equals a squared plus b squared. Okay, so I've got, again, Pythagorean's theorem is kind of what it looks like. And then I think minus those two letters, minus 2 AB, so I have two letters, AB, 2, and then the two letters AB, and then cosine of capital C. Okay, so we want to find that angle C. And I didn't make a table for this. I have everything labeled. I have a picture instead, so I can start to plug in as needed. Okay, and I could do that. I could plug in these numbers right now, but what I'm going to do on this problem is I'm going to solve for this angle C by keeping these letters the lowercase, and then at the very end I'm going to plug in the numbers. Okay, so I'm going to solve for this angle C, which means, well, I should subtract, well, let me box it. So I'm solving for this. I want that by itself, and then eventually I'll get little c. Okay, so what I'm going to do then is subtract these on over. Okay, so like that, nothing combines, they're all staying separate, but we would have c squared minus a squared minus b squared equals negative 2ab cosine of c. Okay, so again, I'm still trying to get this by itself, so I can subtract things over. Okay, notice on the one above, I didn't want to move anything over because the one letter that I wanted was immediately by itself. Okay, so when solving for a side, it really is an order of operations problem. When solving for an angle, it's moving things around in the equation problem, regardless if I plugged in the numbers at the beginning or not. Okay, so I'm still solving for this cosine of c. So we would divide then by this negative 2ab. And then that's going to be it on the left side. C squared minus a squared minus b squared over negative 2ab is cosine of c. Okay, and then now we got to go back and think, well, I do want the angle, so I do want just c by itself. So to get that, I need to use inverse trig. So we need to do the cosine inverse of both sides. Squeeze that in there so that our angle c will be left alone, or all by itself. And remember, we can do this because we can see this triangle. C looks like it should be a defined angle. Careful sometimes on other problems with compositions. Sometimes they might try to trick you, but on these problems it works just fine. Okay, so we've got our angle C now solved for. So angle C is the cosine inverse of c squared minus a squared minus b squared all over negative 2ab. All right, and then so what we're going to do is now plug those values in. Let me put the angle C on the left as well, but I've got angle C is equal to cosine inverse of, okay, so now I'm just plugging these values in. So we have 11.5 squared minus a is 12, so minus 12 squared, minus b is 15 squared, all over negative 2 times a is still 12, and then times b is still 15. Okay, so because they gave us nastier numbers, like the 3-digit number, 11.5 squared, without a calculator, is a little annoying, but the way I'm just boxing this right now, because they want an exact value answer. So this is why I solved for these letters, or I solved for it in this way first, because I saw those numbers weren't the friendliest to do without a calculator. And so I just wanted to set it up to say, hey, this is the exact value answer. If they're not going to be friendly with the numbers, exact value answer, there we go. If they're not going to be friendly with the numbers, we can leave it like this. Okay, so if now instead these were like 4, 5, and 6, then we would say, yeah, we could do those pretty fast, and we should simplify everything as far as we could. Okay, so some gray areas in math with exact values, but if they're telling us no calculator and they're giving us 3-digit numbers to square, then they're being a little unreasonable for us to do that scratch work. Okay, so that is what I'm saying is exact value answer. Now, most of the time we need decimals in these problems anyway, so this is what I'm going to type into the calculator. Okay, so our angle C, so we need cosine inverse, so I have Desmos still open. So I have cosine inverse, remember that's in the function menu. Cosine inverse, and then I need a fraction bar, and then I need to type all that stuff in. Let's see, 11.5. Oh, it moved it. 11.5 squared minus 12 squared minus 15 squared all over -2 times 12 times 15. There we go. And then to one decimal, we would have 48.9 degrees. Okay, so 48.9 degrees. There we go. That's it. There's our approximated angle. Okay, and then now, again, like the last one, if they said, oh, now solve for the whole triangle, not just the single letter, well, we could go back to the law of sines at this point, because now we would have the whole bottom known, because those were the sides, and then we would have one of the angles, the angle C. So that means this fraction would have been complete, and then we could have solved for the missing parts on the others. Okay, so that's the strategy that I would use if it was to solve for the rest of it. Okay, but that's it. We're just finding the angle. If you do have questions on that, or if you want to try to find the missing stuff, go for it. And if you get stuck, let me know. Otherwise, thanks for watching, and I'll see you again next time.